Good day everyone, and today we're going to learn how to use the Coil command in Inventor. The thing that I'm going to be drawing with the use of the Coil command is this. Specifically, just this coil. Except I'm going to draw it better than what I did here because I did not know what I was doing when I drew this. So, first things first is to start a 2D sketch. We're going to use the XY plane. And I'm going to put down a line. This line will operate as your axis of rotation. You can use the X or Y axis, but I find it a lot more convenient just to put down a line. Next thing to do is to measure out the distance between your main axis to the actual shape that you want to use the coil command on. So for now you just throw down a line. We can dimension it later. And the thing that we will be dimensioning here is a circle. So we'll just put a circle down. So next thing to do is to dimension these parts so you have the appropriate, dimensions. So first things first is to dimension this line, and this line from the part that I am deriving this from is 3/8 of an inch. And this diameter is 0.1205 inches. Alright. And from there, all this is properly dimensioned. You can just finish that sketch. And next thing you want to do is to use the coil command. So once you click coil up here, it'll automatically highlight this profile for you. But now you want to select your axis, and that'll select it automatically. If it does not, then you just click on it. Click on the axis that you're going to rotate around, and it's automatically going to show in the green lines what your coil is going to look like. And it's probably going to look weird or like a spring, because that's mainly what this command is used to design. When it comes to the actual behavior of this, there are multiple methods of actually designing a coil. So you can have one of those methods being, if you know the pitch and you know the revolution, you can put in the pitch and revolution. And now I'm going to get rid of this taper real quick so I can show you more so what these values mean. So revolution is fairly simple. Revolution is just how many times this revolves completely. So it's got the revolution of 6. So you can see it goes 1, 2, 3, 4, 5, 6. And here you can see that the pitch is 5. And now it doesn't quite seem evident what pitch is. So my way of showing this is by putting it on its side like this, and now you can see that it's a sine wave. And now if I adjust the pitch to be, say, 1 inch, did you see the difference? The main difference is the fact that the period has doubled from what it was. So the pitch just changes the period of the sine wave. So if we put it back to 0.5 inches, then it just moves it back towards it. So it's literally just the space between your starting point and this point, basically half of a revolution. Well, it's a complete revolution for it, but it's half of the wavelength, I mean. Sorry if that explanation isn't the best, but that's an explanation that I seem to understand. So, from here, the best way that we're able to actually draw this into something like this is from what you're actually given. And to know the best method for you to draw this in is to just see what parameters you're given. In this situation, I do not know the pitch, evidently, but I do know the height. So from here, I can go ahead and put in my height, which is 3/3/8 of an inch. And the revolution, as we can see here, is about 1, 2, 3, 4, 5, 6. So then we have the revolution as 6. And then the taper, the way that I was able to determine the taper is mainly by the fact that I was given a diameter at the bottom of the spring, or coil, sorry, and then I just matched, basically changed the value of the taper until it actually matched the diameter of a circle down here. That's more of a janky way to do it, but there is no other evident way to find that out with the parameters I was given. I did a lot of finagling and I discovered that the taper was 22.25. So if I go ahead and press OK, then you will see that we just created the same spring that was created over here. Now, one more thing that can be done inside a coil is the close to the start or the close to the end. Now, a close start this is more so just used to flatten out the top or flatten out the bottom. So from here you can actually see that the top here has become flat, and you can change the transition angle down here to be something like 180 degrees. And if you can see the difference here, it basically just changes how rough the transition is between the actual flat part and the coil. Usually this is just set to 180 to make it nice flat and then transition smoothly into the next period, because it goes from this stays flat from 90 degrees to this stays flat for 180 degrees. And you can see that after 180 degrees, it starts coiling downwards. And then if I were to change this value to 90, you can now see that it only stays for 90 degrees. And then it starts to coil around. And the same thing applies to a closed end. So this also just stays flat for 180 degrees, and then it starts its transition. For the way that this coil is designed, there is no closed end and there is no closed start. So there is your coil.